Welcome back, friends. Thanks for being here. Buckle up and subscribe because it's going to be fun. Today, we're going to put this on this. Let's get to it. Okay, so just to break up the monotony of that a little bit, what you might have seen me doing is giving it a little bit of a flick. I don't know if the microphone's going to pick that up very well or not, but you get this kind of a ding sound that indicates that you've got a good solder joint on there and it's okay to cut it. So let's put a fresh component through and just kind of hold it in place loosely. And you don't get that same kind of sound. It sounds kind of flicky instead of, solid. Ding, ding, flick, flick, flick. I don't know. Hard to describe, but it's a good way to check out your work as you're getting ready to cut all the legs off. That way you know that it's actually soldered. So you can kind of feel it, you can kind of hear it, you can tell there's a difference there. Try it out yourself, see how that feels. But it's a real good way to know that you've actually got the components soldered in place. These are all tantalum capacitors. And the big difference between a tantalum capacitor and I guess the other kind, electrolytic capacitors. These are kind of like little pills, little bottle shapes, and there's chemicals inside, and they all work a little bit differently, but they kind of, in the end of the evolution, they do the same thing. These guys have a polarity, and everything that I have read says that tantalum capacitors do not have a polarity. So I'm just putting these in the same way I put the resistors in. I am making sure that they all have all their markings going in the same direction, so that way it looks like I actually care about what I'm doing. Let's get back into putting the rest of those capacitors in. Okay, so the next parts on here are C12, C17, C20. There's one line in the instructions and one checkbox because all of these are the same at 1 microfarad. And I'm looking all over my sheet here to try and find them. The only thing I have that's a set of 3 are these 331s, and they are not the right thing. And then I read the instructions a little bit longer and it says the long lead is plus. And we pick up the board and we're looking for C12, C17, and C20. And C12's got a round footprint, C17 has a round footprint, and C20 has a round footprint. See if you can see that at all. Yep. So that means it is these guys. And it says in the instructions that the long lead is plus. Long lead is positive. And on the board there are positive symbols, plus signs for the long lead. So again, we're looking for a set of 3, 1 microfarad. So even if you can't read, you can kind of tell that, first off, this one's blue, everything else is black. So we put the blue one off to the side. Done. And then these 3 match up in size, and this one is an obvious size difference. Done. Process of elimination, even if you can't read and don't feel like getting out your old man cheaters. So let's get these guys put in place. Okay, so the next part of the instructions says 2 more electrolytic capacitors. These are C3 and C6. And where are they located on the board? They are located here and here. And they are 100 microfarads. So in this case, in the last iteration I showed you that I had a blue one and a black one, and I had the 3 that matched, and I did a process of elimination that way. These ones are the same. It is either 2 different batches or 2 different manufacturers. But I can't do the process of elimination because one is blue and one is black. So in this case, I actually do have to read. So read them, they are the same, good to go. Let's get them in place. That all went pretty quick, so we're going to do a couple of extra bonus parts in the manual here, starting on page 5. This is the 7809. This is a voltage regulator that will convert voltage down to 9 volts. On the footprint, it goes right there. And this little piece here is part of your ground plane, and this whole back part here is a nice big piece of metal. What it winds up doing is making it into a heat sink to try and deal with some of the heat. These things are pretty inefficient. There are better ways of doing this, but not really cheaper ways of doing this because of quantity. And so this thing just goes into place, and you want to get it in such a way that it bends over to line up with that screw hole, because you're going to put a screw through it and bolt it down in place. And just to make sure that all works, what I'm actually going to do is put the screw in and tighten it down before I do the soldering, so it's a nice neat job. So put the screw through, hold it in place, get that nut on the back side. You're not trying to kill this thing. I mean, you're bolting something to a piece of plastic, so use the appropriate amount of tension to make that happen. And let's get her done. So one of those is voltage input, one of those is voltage output, and one of those is ground, and if you touch them together in the wrong way, you will zap the component. However, because of the design of the footprint, you kind of can't put it in wrong. I mean, I guess anything's possible. And you can tell that the middle pin is ground because it took a while to heat up. And then those are relatively close together, so I just want to check to make sure that there isn't any connection there that shouldn't be there. Solder bridge. So we put our multimeter into continuity test mode. Touch the two leads together, it makes a nasty noise at you. And as far as I know, there shouldn't be any continuity between any of these guys. So there I'm touching the pin that the other probe is touching. And you can see that all works. But between those other guys, there's no continuity. So good to go. Alright, next up are these SIP sockets. They're kind of like female header pins. And on the footprint you can see that there is an extra square indicating, I guess, where pin 1 should be. But it kind of doesn't matter because this is just a straight through type job, not a not directional, because there's nothing that it's connected to on the other end at this point. So what I do with these guys, you might have seen in some of my other videos, is I put a little blob of solder on the tip of the soldering iron. Well, more than a little blob, pretty substantial blob. And make sure you're not touching any of the metal on the other side because the heat does transfer through. And then just kind of get a dab of it onto your pins and your board. There's a lot of different ways to do this. Maybe I picked the wrong pin to do that with. Yeah, it should be fine. A lot of different ways to do this. This is just one of them. The blue tack sticky stuff you use to hang stuff on the wall works, or painter's tape or whatever will work. And I don't know if you can see that very well, but you see that there's a gap between the component and the board, but it's pretty well hooked in place. And this is why you do this one step at a time here. What I'm going to do now is heat it up, push the piece through, and there we go. Now I fixed that problem. It's all nice and neat. You can verify that it's pretty upright, how you want it. Maybe move it over just a little bit. And now it's held in place and I can solder the rest of it home. And once I get the rest of it soldered, I can go back and touch up any ugly nastiness I made on that first pin. Clean that up a bit. Check my work, looks pretty good. Nice and straight on the board. And then we'll repeat the process for the other side. Alright, that one's held in place nice. It's flat and level and perpendicular to the board the way I want it. And I got a little solder bridge there. I'll show you how to take care of that. It's really because there's too much solder on the tip of my soldering iron. So you just kind of put your soldering iron between them. Capillary action, surface tension, all that jazz gets the solder stuck to the soldering tip, and then you can wipe it off in your soldering stand. I have a Hacko FX888D soldering station that I use, and it comes with this neat little stand. And I have found over time that I really prefer to use just the steel wool scrubby thing that's in there. I guess it's actually brass to be technical about it. And I don't really use the sponge at all. And it works out pretty well. So dab it in and clean it off. Nice shiny tip, good to go. So that's how you clean that off. So those parts lined up pretty nice. I don't know if you could do it any better with tape or with the blue tack, but close enough for what we're trying to accomplish here. Next up are a couple of dip sockets, and find out where they go on the board. Dip sockets have a notch in one end, and then on the footprint there'll also be a notch. And this is really to tell whoever's working on this thing in the future that the notch on the chip matches the notch on the socket, matches the notch on the board, and everything's lined up the way that the creator expected it to line up. And again, I'm going to do the same thing here because there's only a small handful of these. I'm going to get a nice blob of solder on my soldering iron, and I'm going to make sure my hands are out of the way, get one pin in, and now it's being stubborn. Alright, check my work, flat to the board, proper orientation, that one looks good. Let's put that one in there. I think I already have enough on my soldering iron to do this one. Felt that come through. And see, this one's not cooperating. So what I'm going to do with this one is I'm going to tape it in place. And same deal, tack down one corner with your soldering iron, make sure that your work is the way you want it to be. And then once you're happy with it, solder it home. And there you go. So as you could see, the tape wasn't really there to be a professional masking job or anything like that. It was just to dab the part in place so I got a free hand. That was it. Okay, next is the headphone jacks. These ones are right next to each other. They're relatively flat. I'm going to go ahead and tape these ones down and knock them out. Seems like that might be the faster way of getting this done. And I already have the tape out. These have a little bit bigger holes in the in the circuit board, and these are also physical connections. You're going to be putting headphone jack and microphone jack in and out of these guys fairly often, and so you actually want to wind up using a bit more solder than normal to handle that extra stress load. Alright, those are good. Nice and flush mounted. Next up are the MOSFETs. They look like regular transistors with 3 pins. They've got kind of a half moon shape, and they go in this little circular area right here in the center. And all the instructions say is to make sure that it lines up with the footprint on the board, and there's a half moon shape on the footprint on the board to go with it. You've got to spread the pins out a little bit to get it to line up properly. So stick that in place, work it down as far as you want it to go down, and then spread the pins out on the back side. And I'm going to go ahead and solder these in one at a time as I do it. This one goes right next door to the other one, but it is 180 degrees in the other direction. And looks like some of my previous work got some solder in that hole. So what I'm going to do is start out with a little bit of solder braid. Double check the hole that I'm working on. I saw it clear for half a second. These components here are really close together on the board. Alright, desoldering is one of my least favorite activities. And sometimes you just need to add more solder to get the desoldering done, which doesn't make a whole lot of sense until you think about it in terms of heat conduction. And what you're trying to do is get a lot of heat in, so the extra solder helps to flow the other solder by getting all of it warm. Anyway, it'll make sense when you actually do it, because you'll see it working. Oh yeah, he was right, that does make sense. Another thing that you run into is that there's a ground plane on this board. So everywhere on this board that you see solid green is actually a solid piece of copper underneath, and that will pull away some of the heat, and it will interfere with either your putting a soldered component on or taking a soldered component off by changing the whole thermodynamics of the system. And I'm sure there's some mathematical equation that ruins all the fun of this, but I don't care. Alright, we got 2 out of 3 in, and let's get that last one in. These are a little bit more complex components also, so I'm treating these with the same kind of heat sensitivity and not really dwelling a lot with my soldering iron on each individual leg. And it's probably one of those things where as long as you're cautious about it, that's good enough. I wouldn't try and figure out how much time you needed to spend or what the right temperature was or anything like that. My soldering station is set at 640 degrees Fahrenheit. And this one guy I was watching the other day was like, yeah, that's 640 degrees in Fahrenheit. And for those of you that haven't landed on the moon, that is whatever it converted to in non-moon landing country units. Anyway, 3 out of 3 done there. The next is a part that looks almost exactly the same, and that is a NPN transistor 2N3904. And so we've got 3 of the MOSFETs and an NPN transistor. And as you can see, they all look the same. So I had to pull out my handy dandy old man magnifying glasses. That's a 170. And there she is. And these two must be 170s then. And this goes in Q7, and same thing. Make sure that the component lines up with the footprint. Spread the legs a little bit so it gets in there. What I think is going to be really fun is I'm hooking up this $20 radio to a $400 antenna system. And the question is, between the radio and the distance it takes to get to the antenna, is there actually going to be any signal coming out of that antenna? I guess we will find out. Alright, this is one of those things that is pure genius but makes perfect sense, and I never thought about it. Usually when I get LEDs that are clear and I don't know what color they are, I have to get out a breadboard and hook up some resistors and a little 9-volt battery and go crazy. And this is written right in the directions, so QRP guys, way to go, thank you. Take a coin cell battery, which I just finished organizing my shop and put these away in the other room, so I had to go get them. And take your LED and attach it to your coin cell battery. That's the green one. The green one goes on D5. And the LEDs themselves are, obviously they're diodes, so they only allow power to transfer in one direction and not in the other direction. And one of them has a longer lead. And if you look real closely, there's actually a flat edge on the diode, which is this one, which corresponds to the short leg, but it also corresponds to the flat edge on the silk screen. So put that in, double check that you got it the way you want it. And just for grins, doesn't work in one way, works in the other way. And that's the red one. So power does not transfer in that direction, and power transfers in that direction, and it also makes some light. Flat sides on the short leg side, put that together with the silk screen. And then because those have flat bottoms, I just heat the solder up a little bit and get it to nest home properly, just to make it look pretty. Two more parts down. Now we have two 2K trimmer pots. And if you remember back from the first video, we got everything all sorted out. So I've got 2 trimmer pots in the trimmer pot section of my wife's muffin tin. Thanks again. And we'll get those put in. These have a 3-pin footprint, and so they can only go in one way, so that's pretty easy. This is the audio level. Not only do they only go in one way, they also only go in so far. But they do kind of hold themselves in place. One down. Alright, and it's fairly easy. This one is for bias, and this one's not holding itself in place as nice. So we'll grab that piece of tape from before. If you're the kind of person that likes to talk to yourself while you're doing something, then maybe making videos of assembly is for you. Because now I can just tell people I'm not talking to myself, I'm talking to all you guys. Alright, those are both in place, they both look pretty good, and I'm not really going to bother with trimming them just yet. I might trim them a little bit later if I get frisky. Oh, there's a trick in the instruction book. It says relay. Not specifically labeled, but should be obvious where it goes. I don't know if I can figure this one out or not. Not only is it obvious where it goes, it also can only go in one way because there's a offset of pins. So there you go. And I don't know a whole heck of a lot about soldering relays down. I think this might actually be the very first relay I've ever soldered. So I'm going to tape it in place and I'm going to act like it's an expensive, sensitive piece of equipment. You can't go wrong being too careful. Alright, power jack. This one seems fairly obvious that it might go here, but for some reason it's not real happy about fitting into the hole. And that's because this pin on the back side is moved out of the way of where it should be. Move it back where it belongs, and look at that. And again, this is a component that gets a lot of use, so you can see that it's got larger than average solder holes, and you want to put a larger amount of solder than average in those holes in order to give it some physical strength to hold it in place. Now it's just taking a whole lot of solder. How do you know when it's enough? I like my components to have a nice little pyramid or conical shape of solder when they are put in place. And since this is a power jack, it's meant to transfer heat, so you can dwell on a little bit longer. And there we go. Antenna jack. And this one actually has your inside and your outside, and then 2 specific poles for your tension. And your center conductor is actually mounted in some plastic or dielectric or foam or something. So you don't want to put a lot of heat onto those guys, but you can obviously put a lot of heat onto the physical attachment pin. So just be aware of the differences between those two. And they were ever so slightly out of alignment, so it winds up just holding itself in place. So I'm going to go ahead and solder in the hold down lugs first, very quickly on the center pin. Alright, so for this next piece, it is called BAL, and there's BAL and there's balance right next to each other. In the instructions it says that they found out later that they did not need the balance portion, so there's nothing to put there. And it is a 2-pin clip off of a larger row of headers. It's already clipped for you, don't have to worry about that part of it, but as you can see, it's got the metal pins that come straight through the piece of plastic. So if you're trying to hold this in place with your hands, you're going to get some warm sensations There isn't really an orientation of this part. Again, this is just a physical connection straight through, so I'm putting that in. It's actually doing a pretty good job of holding itself in place, but I'm going to keep that jumper on there in case I do need to make an adjustment. Now I got to find it. Where did it go? Okay, there she is. And just pull away some of the extra solder that was there. That's all good. I'm going to go ahead and put this in the open position for now until I learn better farther down the line in the directions. And then the next is the BS107 transistors again. These parts get mounted up here in this area, Q6, Q4, Q3, and the flat side goes down against the board. And it turns out that these apparently aren't as heat sensitive as I thought they were, because the whole purpose of doing this is to deal with some of that heat transfer. So I'm going to get these components in place. And what they say is after you get these things put in place, wrap a paper clip around them and solder that paper clip in place to help with the heat transfer, or better yet, get yourself a piece of aluminum and use some 440 screws to hold it down. And then what you should do is put some heatsink compound in between the parts and the metal bar, and I'll do that afterwards. And what heatsink compound is supposed to do, you want to use a really thin layer of it. What it's supposed to do is just deal with any surface imperfections and make sure that you've got a good clean mating between the part that you want to pull the heat from and the part that is used to pull the heat away. And then obviously, because you're dealing with some heat here, if you ever do decide to put this in a case, you want to take that into consideration as well. And I'll tape those down just to make sure they're fairly close contacting the surface there. I'm not going to spend too much dwell time on these guys either. Alright, they all sound pretty good. Let's get them cut. Okay, that winds up being all of page 5. Okay, I'm going to try the paperclip method myself, and I've got some heatsink compound here. This is MX4 thermal compound Arctic. I just got it off of Amazon. So lift these guys up a little bit, put a little dab there, and then I'm going to use a toothpick to spread it around. Probably should have dry fit the paperclip before I did the thermal compound, but we'll live. And I gotta go find my pliers. I'll be right back. And through the magic of video editing, you guys didn't even miss me. Maybe next time. So what I'm gonna try and do is get this thing bent into a shape that also gets that middle one held down well. And this is just a little fiddly bit of work here, nothing terribly fancy. So there's a little bit of a dip in the center of the paperclip. Let's see how that works. Well, that wound up lining up pretty good. I'm gonna pay some attention to bending that over and making it nice and tight. And same thing there. And I have no idea how this is going to solder, so let's have some fun with it. Not too bad. I think that turned out pretty neat. And that's hot. Alright, do not use your solder leg cutter, side cutter deals on this, because it is a much thicker piece of wire. So I'm actually going to use the wire cutters that came with these pliers. Alright, there we go. So we've got the thermal compound in place, and we've got the bent paperclip holding it in place, and I may want to visit that again with something a little finer, and I'm only just nibbling away at it with these side cutters, just to try and get the sharpness off. So I'm only cutting the thin little part. Don't think I'm not heating my own morning there. That would be blasphemy. Alright, add a little bit more solder to it, because I can. Alright, and there you have it. That gets us to the end of page 5. Next up is the daughter boards. So we'll get those taken care of in the next video. And then finally we'll get down to winding some toroids and testing it out. So that's it for this one. Thanks for being here. And check the description below for information on some of the tools that I used and where you can get your radio kit to work on. And be sure to leave a comment if you have any thoughts on anything I could have done better. And we will see you in the next one. Thanks again.